Hi. In this video, I'm going to cover a few questions that have appeared in the Cambridge A-level papers, which are not completely straightforward. There are slight variations. They're not hard to do. I just wanted to go over a few of them. So the first question says, sketch the graph of y is equal to modulus of x minus 2a, where a is a positive constant. Now we go about this in the usual way, which is we will try and plot this without the modulus sign. So if I put in some values for x and y as before, I want to focus on finding the value of y when x is 0 and x when y is 0. So when x is 0, y is minus 2a. Remember here it says a is a positive constant, therefore this whole value is a negative value. And when y is 0, x is going to be 2a, which is a positive number. So now I'm going to plot it. Drawing the axes. Right, so I'm just going to assume that this is a and this is twice a, and this is a and this is negative a and this is negative 2a. Negative a and negative 2a on the y-axis. So when x is 0, y is negative 2a, which is down here, and when y is 0, x is 2a, that's here. I'm going to join these using a construction line, which I'm showing in yellow. Extending it, remember modulus function is always above the x-axis, and then I'm going to complete my V shape. So since it passes through minus 2a here, if I reflect it above the x-axis, it's going to pass through plus 2a. You would actually you would do this using a scale and proper straight lines. I'm just going to go over the final graph like this. Okay, and I've shown both the intercepts. The x-intercept here is 2a and the y-intercept is also 2a. And that's the sketch of the graph of a modulus x minus 2a. Part B of the same question asks us to solve the inequality 2x minus 3a less than modulus of x minus 2a. Now remember, we've already plotted x minus 2a in the previous question. I'm just going to redraw it here real quick. It was like this. Okay, this point was 2a, a is somewhere there. Just quickly marking out the... Okay, this was our graph of modulus of x minus 2a. On the same one, in the same graph, if we plot y is equal to 2x minus 3a, I'm going to put in some values, specifically when x is 0, what is y, and when y is 0, what is x. So when x is 0, y is minus 3a. That is this point here. And when y is 0, x is going to be 1.5 times a. Okay, so this is 2a, this is a, 1.5 times a is right there in between. So when y is 0, this is the point I want to mark. I'm going to join them. Okay, so these are the two graphs. The V-shaped yellow graph is of modulus x minus 2a, and the green graph is of 2x minus 3a. And they want us to solve such that, basically find the x values such that the left-hand side, the graph of 2x minus 3a, is less than, it's below the modulus graph. So where is the green graph? Below the yellow graph. So we notice in this section here, from here, just marking that in red, from here and all the way to the left, the green graph is below the yellow graph. Okay, so we need to find this point. In order to do that, so since there is an unknown constant in the picture, I don't want to square both sides because it becomes too tedious, and you'll notice this is just 2 marks. We've already done a lot of work. So I'm going to use another method to figure out this point. So 2x minus 3a less than, first you use the positive of x minus 2a, remove the modulus sign, just write x minus 2a. Okay, when we solve, we get x is less than minus 2 plus 3a, which is x is less than a. Okay, that is not the point we're looking for, right? X is equal to a is this point. We're looking for something to the right of a. So I'm going to use the equation again, 2x minus 3a less than, and now for the modulus, because what's inside the modulus could be positive or negative, I'm going to use negative of x minus 2a. Here I used positive of x minus 2a. So when I simplify this, I get 2x plus x less than 2a plus 3a. So 3x is less than 5a, and x less than 5 by 3a. Okay, this is the correct solution. This could be 5 by 3a, and to the left of this, for all x values to the left of 5a by 3, you'll notice that the function 2x minus 3a lies below the modulus function. Okay, so this is the next question that I want to cover. It's from the 2022 May-June paper, paper number 33. So it says, find in terms of A the set of values of x satisfying the inequality 2 modulus 3x plus a less than modulus 2x plus 3a. Okay, so there's a modulus on both sides. It should be fairly straightforward, except that there's a constant a. So if we end up with a quadratic, we will have to solve it like using the quadratic formula. Can't put it into our calculators. Okay, so we're going to go about it the way we like to, which is to square both sides. Remember to square the 2 as well. So 2 squared into 3x plus a, the whole square, is less than 2x plus 3a, the whole squared. So that is 4 times 9x squared plus a squared plus 6ax. The whole is less than 4x squared plus 9a squared plus 12ax. Right, I'm going to expand this. So 36x squared plus 4a squared plus 24ax less than 4x squared plus 9a squared minus 12ax. Remember, this is a 4 marker. We can take our time doing this. 36 minus 4 gives me 32x squared, and the 24ax plus is this plus? No, it's minus. It's not minus, it's plus, huh? Okay, so 24 minus 12ax is plus 12ax, and 4a squared minus 9a squared is minus 5a squared less than 0. So I'm now going to solve this quadratic using the quadratic formula. Remember, the quadratic formula is x is equal to minus b, which is the middle term, plus minus root of b squared minus 4 into the coefficient of the first term into the constants divided by 2 times the coefficient of the first term. So in this case, x is equal to minus 12a. This is b, this is a, and this is c. So minus 12a plus minus root of b squared. So 12a squared is 144a squared minus 4 into 32 into minus 5a squared. The whole divided by 2 times 32. Simplifying that, minus 12a plus minus root of 144a squared. The minus and the minus become plus, and 4 into 32 into 5 is 640a squared. 640 divided by 2 into 32 is 64. So that becomes minus 12a plus minus root of 144 plus 640 on my calculator is 784. So 784a squared by 64. That becomes minus 12a plus minus root of 784 is 28, and the root of a squared is a by 64. So I will end up with 2 roots minus 12a plus 28a by 64, or minus 12a minus 28a by 64. If I were to simplify the two of them, I would get 28 minus 12 is 16. 16a by 64, which is 1/4 of a, or I would get 28 and 12, so that's minus 40 a by 64. If I were to simplify 40 by 64, I would get minus 5/8 of a. Okay, so those are my 2 roots. Now all I have to do is look at the inequality sign. So it's a less than. Since it's a less than, the root x lies between sorry, not the root x. X lies between the two roots that we found, which is the negative 1 goes on the left, minus 5 by 8a, and 1/4 of a. And that's the solution. The next question is from the year 2021, October-November, paper number 32. Once again, we see that it's got a modulus on both sides. So modulus 3x minus a is greater than 2 times modulus x plus 2a. Modulus on both sides, so we'll be squaring both sides, solving the quadratic, and presenting our answer as an inequality. So let's start with squaring both sides. X minus a the whole squared is greater than, remember to square 2 as well, 2 squared, x plus 2a the whole squared. That gives me 9x squared plus a squared minus 6ax greater than 4 times x squared plus 4a squared plus 4ax. 9x squared plus a squared minus 6ax is greater than, I'm expanding the right hand side, 4x squared plus 16a squared plus 16ax. Simplifying this, gathering the like terms, we get 5x squared minus 22ax minus 15 is greater than 0. If I put these values into my calculator, I get x is equal to 5 and x is equal to minus 3 by 5. Now we just have to present our answer as an inequality. You'll notice that the sign here is the greater than sign. And so x is greater than the larger value and x is lesser than the smaller value. And that's the solution.